Hello everyone. In this video, I'll be talking about a very specific test, which is called the match pairs test. This applies to dependent samples. So let's start with the definition of dependent sample. These samples are samples that are paired or matched in some ways, while independent samples are samples that are drawn totally independently of each other. Let's take a look at what we mean by dependent samples. For example, samples in which the subjects are used in pre-post situations are dependent. They are matched, right? Another type of dependent samples are samples matched on the basis of variables extraneous to the study. So as long as you see a way that the samples are matched, we are talking about dependent samples. And in that case, we have to perform a matched pair test. So the matched pair test is actually one simple t-test. It's a t-test, and it's used when samples are dependent. However, the way we define and test the parameter, it's a little bit different. So we have to be very careful of how we do this. The parameter we are investigating has a notation. It's mu sub d, which is the mean of the differences of all matched pairs. So we have to focus on finding the differences of all matched pairs. The random variable is d, which is the difference between x1 and x2. So these are, of course, the two matched values. The test will follow the same steps of hypothesis testing. And the first step will be to set up the hypothesis, because we are doing this test in a very specific way. We use very specific notation. So here we have all possible notations for a right-tailed test, a left-tailed test, and a two-tailed test. So a right-tailed test will be mu d less than or equal to 0 for h sub 0. And for h sub a, mu d is greater than 0. Right-tailed test. A left-tailed test, mu d greater than or equal to 0 for h sub 0. And h sub a is mu d less than 0, while a two-tailed test is mu d equals 0 for h sub 0, and h sub a is mu d not equal to 0. Now think of this mu d as the difference of all matched pairs. So if we are comparing mu1, so let's just give an example right here, with mu2, and we say mu1 is less than mu2, and we used to do this for testing two means. Now, subtracting mu2 from mu1, we get the difference. And that difference is actually less than 0. In order to understand what we are doing here, it's really important to see that this is the difference. And what we are using for the difference when the pairs are matched, and we're doing a matched pair test, is mu d. This is the notation, mu d less than 0. So that will be equivalent to a left-tailed test. I just want to make sure you understand where this mu d is coming from. It is from the difference of all matched pairs. So here is the general procedure. First, we will have to find the differences of the values of the pairs of data, and that is denoted d, difference of the values. And then simply do a t-test on this new data set. Degrees of freedom, because it's a t-test, of course, we need a degrees of freedom. So degrees of freedom goes by the same formula, n-1. Just keep in mind, n is the number of data pairs. So what we do on the calculator, we will do a t-test on the differences. So basically, we will have in list 1 a set of values, in list 2 a set of values, and in list 3, we will actually enter the difference between L1 and L2. And our test, our t-test, will actually be performed on the values in list 3. That will be a t-test performed on the difference. Let's do so on the following example. A farmer has decided to use a new additive to grow his crop. He divided his farm into 10 plants and kept records of the corn yield in bushels before and after using the additive. The results are below. Let's take a look at these results. So we have row for before and after using the additive. The question is, at a level of significance of 0.05, is there enough evidence to support the claim that using the new additive increases the corn yield. So I'll write down the given information, and I will simply say I have data, raw data, and I will also add that we are dealing with dependent samples. And why? Well, because this is a before-after situation. Okay, we have this in the table, and alpha is 0.05, and I'll also try to see which one is the claim. The new additive increases the corn yield, meaning the after results should be better than the before results. I'll simply say, okay, mu before is less than mu after. That's the claim. So the question, do a matched pair test, and let's do that. And we'll be using the p-value method first because it's a matched pair test. I need to write this in a very specific way, h sub 0 and h sub a, because I'm comparing these two, mu before is less than mu after. I will write down mu d as mu before minus mu after, and that happens to be the claim, and mu d then will be less than 0. So usually we define the difference as before minus after, in which case we have this as the alternative hypothesis. It is strict inequality, and this is the claim, and this is the left tail test. Now, mu d greater than or equal to 0 will be the null hypothesis. Step 2, what distribution do we use? Well, we will be using the t-distribution. This is a regular t-test, and alpha is 0.05. Now, how do we use the t-test? And this is very important. On your calculator, we will enter before in list 1 and after results in list 2. And then we will create another column, list 3, which is L1 minus L2, before minus after. And this is actually the column we will be doing the t-test on. So t-test on list 3, which is the column for the difference. So let's take the calculator and do so. Go to stats, edit, and I have already entered list 1 and list 2 in here. So if I hit enter, you will see that I have list 1 and list 2. So make sure you do the same. You may need to stop the video to enter these values. You have 10 values because you have 10 plots. And then on list 3, I'll go to the top of the table, the header, list 3, and I'll simply ask to compute list 1 minus list 2. Second one will get me list 1, and you see it appears right here on the bottom, minus second 2, which will give me list 2. And as soon as I click on that, this list will be populated. This is the difference between the before results and after results. What we do now, we go to stats, and we simply go to tests and choose the t-test, hit enter, and we have data in list 1, list 2, and list 3. However, for data, I will be using the data in list 3. So first of all, what is mu? Mu will be compared to 0. This is what we have right here because we're subtracting one of the means, and we're left with 0 on this side. And I'm looking for list 3, so it will be second 3 because that's where I have the differences. And the frequency is 1. What type of test? We are doing a left-tailed test, so it will be this option. And then scroll down to calculate, hit enter, and here we have the result, okay? Now, keep in mind, when we are doing a t-test, we need to specify the degrees of freedom. So degrees of freedom is the number of pairs, and we have 10 pairs. Minus 1, so it is 9. So step 3, I'll just simply write down the results. It's a t-test value, and that will be a very small one, negative 5.01, and the p-value is a small one too. Look at this, right? So I will have 0.123, and the fourth number, if I round to the first non-zero digit, I get 4. And now I'm ready to conclude the test using the p-value method by comparing the p-value with alpha. Let's do so. P-value is 0.0004, and alpha is right here, 0.05, and I will add 2 more zeros. I clearly see that this is less than or equal to alpha. So I will reject H sub 0, or I use the acronym reject H sub 0. And now I'm ready to interpret the results. I will just simply say at alpha equals 0.05, there blank enough evidence to blank the claim, and simply copy this. This was the claim, okay? Copy it in here. Let's just fill that in. We reject it, so we will put in is. We reject it. There is enough evidence to, and of course we are supporting this claim. This is how we do a matched pair test using the p-value method. Let's continue with another example. In a study of SAT scores, a researcher believes that students will score significantly higher on their second attempt of the exam. To test this claim, 9 students were randomly selected. Their scores on the first and second attempt of the SAT exam are shown below. So on the first row, we have the first attempt. On the second row, we have the second attempt for these 9 students. Use the significance level of alpha equals 0.05 to see if there is enough evidence that the mean score of the second attempt is higher than the first attempt. So this is the claim. I'll write down the given information right here. And what we have is raw data, and we are dealing with dependent samples. It's really important to analyze and making sure we know which type of samples we are dealing with. Is the same student taking the test twice, so before and after, or first and second. And the claim right here is that on the second attempt, they do better. So I would just say mu first attempt is less than mu second attempt. And I will define mu d, because I know I'm dealing with dependent samples, right, as mu1 minus mu2. This is what I will do the test on, the mu d, the differences in those scores. And let's write down that we are doing a matched pair test. And this time we will try to do this one using the critical region method, which is also called the traditional method. So I will write down the first step, which is stating the hypothesis, H sub 0 and H sub A. I will be using the correct notations. I'm doing a matched pair test, so I need to use mu d. And because mu1 is less than mu2, when I subtract mu2, this will be less than 0. This is the claim. So I'll put that in here as the alternative hypothesis. And this is a left-tailed test, which means the null hypothesis is mu d is greater than or equal to 0. And I'm done with the first step of setting the hypothesis. Second step, I know I'll be using a t-distribution. This is a t-test, a simple t-test, which means I need to write down the degrees of freedom. And the degrees of freedom would be the number of pairs minus 1, which is 9 minus 1, which is 8. And alpha, in this case, is 0.05. In order to come up with a test statistic, I will need to perform the t-test. Until then, though, let's find the critical value. So I will find TC. How do we find TC? Well, we will be starting with alpha. So I will sketch the graph. This is a t-distribution with the degrees of freedom 8. And I know this is a left tail test. So I will shape this area. Right here, this area is actually 0.05. So to find TC right here, I'll be using inverse T, 0.05 degrees of freedom 8. So let's do so. I go to variables, second list. Inverse T is option 4. Area, it's 0.05. And degrees of freedom, 8. And then I'll paste. And here is the result, negative 1.86. So this is the critical value, negative 1.86. I'll just say this is negative 1.86. This is the first number that goes in here. Now we know that at this point, this line, the vertical line going through negative 1.86 will split this shape into regions. Critical will be this way and non-critical will be this way. These are the two regions. All we need to do now is find the test value or test statistic, which we will call it T. So now find T. We will find T using the calculator. So let's go ahead and use the calculator. The first thing we need to do is actually enter these values in list 1 and list 2. So let's go back to stats, edit, clear the list one by one, or we can go back to the previous screen and clear all at once. I will clear it one by one for now. And let's enter these new values. Okay, so I have 480, 510, 530, 540, 550, 560, 600, 620, and 660. We have 9 values in list 1. Now let's enter the second score for each one of these students: 490, 520, 550, 530, 580, 580, 610, 640, and 690. Now that we have this in both lists, I will simply go to list 3. And this is what we need to do. In list 3, we need to enter list 1 minus list 2. So I'll simply do second one. As long as I'm at the top, keep in mind you need to be on the top right here. This should be highlighted. You'll enter the command. So the calculator will simply subtract these two. And now you'll have the results in your list. This is the list that we will perform the t-test. Okay, let's go back to stats. We have this in list 3. We'll go to the t-test, which is option 2. Hit enter, and mu sub 0 will be 0 for our class. For these problems, it will be 0. And then L3 is where we have the differences. We are doing a left-tailed test. So this is the option we pick here. Scroll down and hit calculate. And keep in mind, the only piece of information we need from here is actually T. This is the test statistic or the test value. This one, and I'll just round it to 2 decimal places. So T is actually negative 3.78. So what we do now, we take this test statistic and we will place it on the t-axis. Now this number is negative 1.86. Negative 3.78 falls to the left. You can clearly see that far away. So negative 3.78, which means it is in a critical region. Because it was in a critical region, we will reject the null hypothesis. So we are ready to conclude the test. We will say reject H sub 0 because the test statistic falls in a critical region. Or in other words, we can say because T is less than TC, and this being a left-tail test will place T in a critical region. And now interpreting the results, we'll say at alpha 0.05, there blank enough evidence to blank the claim that, and again, copy this down, the mean score on the second attempt is higher than the first attempt, the mean score on the first attempt. So we rejected, which means there is enough evidence to support this claim, because the claim was H sub A. With this, I conclude the video.